So according to our schedule, today we're going to cover section 2.7. Homework 2.6 was due today. That was the stuff with the inequalities. And homework due next time is 2.7. And I just want to point out one other thing up here. Exam 2 will be here before we know it. It is coming up on Wednesday, October 30th, which is 1 week from today. Okay? Exam 2 is 1 week from today. I think I mentioned this before, but typically exam 2, the grades end up dropping for some folks quite significantly from quiz 1, exam 1, and quiz 2. So in order to maintain the same grades you've been getting, might require more work on your part on this tougher exam 2. Any questions on the schedule? Okay, so let's take a look at page 150, and we'll go up here to the top. Let's see. Just a reminder, exam 2 is coming, and there are lots of resources for you as you prepare for exam 2, including that yellow QEF packet, which has a practice exam and more practice problems in it, okay? So lots of resources. Take advantage of those. Okay, we'll move on to the objective. Can we start with Chris? Thank you. Henry? Okay, two definitions right there. They're really important. X-intercept is the point where the line crosses the x-axis, x. So if you take a look at this line right here, I will highlight in yellow the x-intercept is this point right down here. It's the place where that diagonal line hits the x-axis, okay? And then we'll highlight in green the y-intercept is the place where the diagonal line hits the y-axis, all right? That's it. It's nothing more and it's nothing less. X-intercept hits the x-axis. But we're going to make some observations here, and then we'll do some algebra. Would you guys agree, for example, that the coordinates of this point right here are 1, 0? Is that right? Okay, and if I pick this one out here, 1, 2, 3, 4, 5, maybe that's 6, 0. Yes? What's the same in both of those purple points? They're on the x-axis. Caroline? They both have 0 where? Yeah, it's 0 up or down. And is the 0 sitting in the x spot or the y spot? That's the y spot, right? 1, 0, that 0 is the y value. 6, 0, that 0 is also the y value. In fact, any point that you pick on the x-axis will automatically have a 0 in the y value, no matter what. And so what we've done is we've written that right in here for our generic x-intercept is a question mark in the x. I don't know what it is. It could be 1, it could be 6, it could be anything depending on the diagonal line. But one thing I know for sure is that the y value is definitely 0. At every x-intercept, the y value is 0. Does that seem fair? Okay. Conversely, if you are sitting on the y-axis, then which value is definitely 0? For example, what are the coordinates of that point right there? 0, 3, yes? No matter where you are on the y-axis, would you agree that the x is automatically going to be 0? Right, 0, 4, 0, 5. So that is highlighted here. If you are sitting on the y-intercept, the x value is definitely 0. The y could be anything, I don't know. Okay, so here's our big summary. To find an intercept, you set the other variable equal to 0. And let's be clear, to find the x-intercept, you set the y equal to 0. Yes? To find the y-intercept, you set the x equal to 0. So do we understand what I mean by saying this other variable? If you want to find the x-intercept, you let the y equal 0. To find the x, you let the y equal 0. And then the other way. Okay, so let's see how we can do this in an example. Number 1, we'll go to Morgan. Okay, so let's find the x-intercept given that equation. Now, I don't have a line in front of me, so I can't just look at a line and count hash marks and figure out the x-intercept. We're using algebra here. In order to find an x-intercept, we have to let something equal 0. What letter do we let equal 0? Is the y. We see that? We're finding the x-intercept, so we let the other letter equal 0. Everybody clear on where that came from? See, the opposite one equals 0. Okay, so then all I'm going to do is I'm going to copy this equation right here, but instead of the y, I'm going to put 0. Everyone see it? Just replace that y with a 0. And then we have to solve for x. How much is 0 minus 4x? Is negative 4x, thank you. And then what do we do to both sides to solve for x? Divide negative 4, divide by negative 4. Yeah, so we'll go ahead and reduce 2 over negative 4 is really a half, and I always put my negatives in the front of the number. So the x-intercept is at x equals negative a half. And then I'm going to write the actual coordinates of the x-intercept, and I haven't decided at this moment how picky I'm going to be. If I just say x-intercept and you say x equals negative a half, I don't know whether or not that's the right answer. But what I might be looking for, and I'll give you more information soon enough, is that the x is negative 1/2, and how much is the y? 0. That's how we started, right? We know that the x-intercept is a place where the y is 0. So whether I want you to tell me that the x-intercept is just x equals negative a half, or the point negative a half comma 0, I have to decide and let you guys know. But they're both kind of saying the same thing, right? Okay, let's tackle B. In part B, we're going to use algebra to find the y-intercept. In order to find the y-intercept, what do? Let x equal 0. So that equation up at the top, we copy it just as it is, but instead of the x, we put 0. So 4 times 0 is just 0. And y minus 0 is just y. So y equals 2. Questions on that? And just like before, I still don't know whether I want you to write the y-intercept as y equals 2 or as a point with 2 coordinates. Go ahead and fill in the 2 coordinates of the point. Where does the 2 go? That's the second one, it's the y. How much is the x? It's 0. That's how we started this process. Okay, and let's move on to part C. And we'll go back to Caroline. Okay, so the first point we had was at x equals negative a half, but it's the x-intercept, so it's really negative 1/2 comma 0. So ballpark, put that point on your graph. And then we found the y-intercept was at 0, 2. We've got our 2 points on the graph. And we're just drawing the line that connects the dots, right? So that's the graph. Any question on graphing? Plot the two intercepts and then connect the dots with a straight line. All right, so I have two other things to say here, and then you guys will do the group work. So the first thing I want to say is that if you just write, let's circle these in red. If you just write x equals -1/2 for the x-intercept, that could be full credit. I still don't know yet. And if you just write y equals 2, that could be full credit. I don't know. But it is really easy if in part C I say plot the intercepts, it is really easy to say, oh, x is -1/2, y is 2. I can plot that point, -1/2, comma 2. And you will plot a point right around there. And that is dead wrong, which is part of why I'm kind of leaning towards saying, I don't want you to answer these questions like I've circled there. I want you to write the coordinates of the intercepts. Right? It's really easy to say, oh, I have an x, I have a y, Ian wants me to plot a point, so I better plot the point. But that's misleading. How many points are there really? There are really 2 points here. There's an x-intercept. The x is -1/2, but the y is 0. That's a point. And then you have a separate point. So it's really tempting to compress these two things into a solitary point, but it's really 2 different points. The other thing that I'll say is that in a past math class, you guys might have been kind of trained to automatically take equations like this and solve for which letter? Is it x? Maybe you haven't been trained, which is okay, because I wanted to undo the training. But have you guys seen this equation before? Y equals mx plus b. So in a lot of algebra classes, you spend time solving for y. Always, always solve for y. I don't think, yeah, I mean, that's not, it's not the best way to solve the problems that we're doing here. So if you have in your head some default that says, oh, I better solve for y in order to do anything, get it out of your head. You don't need to solve for y. This is very easy to just set the other variable equal to 0 in the current form of the equation. Okay, so last thing here, part D. Catherine? Yes, please. Okay, so there's a line. I want the equation of the line. Finding equations of lines is typically a lot of work. This one is not a lot of work if you know how to find the answer. What is the equation of that line? So what is that equation, Dwight? This is the equation of the line. It's the one that we started with. That's what we did. We graphed that line. So I put that there just to reiterate that you haven't done anything to the equation. You started with an equation and you came up with a way to graph it. And I'll also say that this maybe is a little bit easier than how we used to graph equations earlier this semester, where we would pick, like, 5 values of x and then find the 5 values of y. You'd have to do work for each of those things and plot 5 points. Finding 2 intercepts is very easy to do. Questions on this? Okay, so classwork begins here. So go ahead and go through the classwork. At some point in a little while, we'll come back together and just discuss, but keep going until we get to that point. So on 152, I just wanted to make sure we're all clear on the sentences. So there's what I'm about to write down. You don't have to have word for word, but there will be certain things that I'll be looking for when I grade your sentences. So ultimately, you guys ended up saying that if you let g equal 0, then you did a lot of work. And how much was the value of t? It was 25 in this case. And so I think that when it comes to writing the sentence, I think writing the units for each of these numbers will help you. What were the units for g? It was 0, but what was g measured in? It was gallons. So that was 0 gallons. And what was t measured in? It was time, but what were the units? It was minutes. So your sentence had better incorporate the 25 minutes and the 0 gallons. I think having that gallons there gives us some information. But I don't want you to just say, after 25 minutes, there are 0 gallons. I want you to write some kind of not math word. What are we really saying if there's 0 gallons in the tank? It's empty. So I'm not saying you have to use exactly the word empty, but to say there are 0 gallons is kind of a very clunky way to tell somebody on the street what's going on, right? You would probably just say the tank is empty. Okay, so we're going to say after 25 minutes the tank is empty. But there's one little thing that we need to add to that description. When we say after 25 minutes, we have to have a frame of reference for when we started the clock. Is it 25 minutes from now? Is it 25 minutes from when you woke up this morning? It's 25 minutes since something happened. Since what happened in this problem? Since the leak started. This right here needs to be in your sentence. That's our frame of reference for when the clock started. So if you come down here, so I'll write a sentence, then I'll show you guys this diagram that Sandy came up with. 25 minutes after the leak started. What's true? What happens at that moment? The tank became empty. So I'll just say the tank is empty. Since, yeah, since is fine. 25 minutes since. Yeah, that's right. So there's a rate of change happening here you can describe. So again, you don't need to be word for what I've got up there, but when I grade your sentences on this next test, there are going to be certain things I'm looking for, and this phrase right here, after the leak started, is one of those things I'll be looking for. And so here's the diagram that Sandy came up with. We have, it's easier to look up here because it's in color than in yours, which is just in black. But we have time t equals 0, which is when star happened. Star is some event. In this case, it was the leak. And if you are out here in the positive values of t section, then your sentence is going to have something after star happened. In our case, we said 25 minutes after the leak started, something happened. If we had negative values of t in the problem, then we would say, oh, must have been before the leak started. And if you are right at 0, then you are at the moment when the leak started. Okay? So before, when, after. Those are 3 words that you should be using. You should be using one of those 3 words in your sentences. Before, when, or after. Okay, and then the other sentence, let's see if we can update this other sentence. In this part, we let t equal 0, did some work. What did you find out for g? What is 50? The units there were 50 gallons. The t is still measured in minutes. I have one of 3 words to use. Which word am I using in this problem? Is it before, or when, or after? It's when, because we're sitting right there at t equals 0. So, when, what's the magical event? When the leak started, what was true? The tank had 50 gallons in it. Okay, so to be clear, I'm not looking for word exactly that sentence, but there are certain characteristics of these sentences that if you are missing, you will lose points. And one of them is one of those 3 words, before, when, or after. Questions on that? Okay, all right, so keep going wherever you were. Some groups are really zipping along right here, so they've already jumped to the practice section for this material. If you finish all of the practice for this material, go back to the inequality stuff that we did last time, because that was challenging for a lot of folks.